the whole universe will know about this one blast. A star is nearly at its demise. Have you ever been keen on the greatest impacts in the universe? Every day we see the sun and know it is a powerful force that emits a lot of energy into space. But not so long ago, the James Webb Space Telescope discovered a star called Betelgeuse, which is even more remarkable than the sun. Isn't that incredible? To learn more about Betelgeuse, keep reading to find out everything you need to know about this fascinating object in space. The red supergiant star Betelgeuse. Betelgeuse is so massive that it dwarfs nearly all the other stars in the sky. Scientists are fascinated by it due to its size, unusual behavior, and irregular pulsations. Astronomers studied this remarkable star with the James Webb Telescope and found something astonishing that could reshape what we know about the universe. During winter in the northern hemisphere, you can see Betelgeuse at night. It's easy to spot because it appears as the bright orange-red star in the upper left corner of the Orion constellation. Its brightness changes over time. Even though it's one of the largest and brightest stars, what's happening to it is even more intriguing. When it appears dimmer than usual, it might seem like just another star to us. However, it is more than 640 light-years away. To put that in perspective, it would take over 640 years to reach Betelgeuse traveling at the speed of light, something we cannot achieve. Using our fastest spacecraft, it would take more than 12 million years to make the trip. Astronomers are interested in Betelgeuse because of its enormous distance and size. Scientists are continuously amazed by its immense power and potential, which has led to significant discoveries. The changing brightness of Betelgeuse. The James Webb Telescope could change how we think about stars and the universe. Unlike most stars, Betelgeuse's brightness fluctuates because it expands and contracts. These changes can happen over days or even hundreds of days. Betelgeuse's light can range significantly, from around 0.5 to 1.5 in magnitude. Its brightness cycle lasts between 185 and 235 days, with the shortest cycle lasting around 185 days. At times, Betelgeuse becomes very faint. For example, in February 2021, it reached 1.64 magnitude, one of its dimmest periods in recent memory. Despite this dimness, Betelgeuse remains visible at night, though not as bright as usual. Its iconic red hue is due to its surface temperature of 3,500 Kelvin, much lower than the Sun's 5,500 Kelvin. Although it's one of the brightest stars, its lower temperature means it emits less energy per unit of surface area. Unique characteristics of Betelgeuse. Betelgeuse stands out because its light and size are always changing. Think of it as a giant star that commands attention effortlessly. It's about 20 times heavier than our Sun and has been a prominent star in the sky for centuries. The name Betelgeuse translates to the armpit of Orion in Arabic. Ancient Greek astronomers adopted this name long before modern telescopes allowed us to learn more about this star. Today, advanced telescopes like the Hubble Space Telescope have captured detailed images of Betelgeuse's surface, revealing complex patterns of gas and dust. These images help scientists model the star's behavior and predict its future changes. One of the most remarkable discoveries is the presence of vast gas clouds rising from the star's surface. These clouds are likely caused by Betelgeuse's pulsations, which explain its changing shape. Pulsations and magnetic fields. Inside Betelgeuse, a process called convection causes hot gas to rise and cooler gas to fall. This movement causes the star's atmosphere to expand and contract, making it shine brightly. Interestingly, Betelgeuse is believed to have a magnetic field 200 times stronger than the Sun's. This powerful magnetic field influences the star's behavior and makes it unique. Due to this magnetic activity, Betelgeuse's surface often features star spots, regions with intense magnetic activity. These spots are cooler and darker than the surrounding gas, lowering the star's brightness. On Betelgeuse, star spots can cover up to 20% of its surface, and some are many times larger than Earth. As these spots move into and out of view during the star's rotation, they cause fluctuations in brightness. Other remarkable stars. Betelgeuse isn't the only star with fascinating features. Other variable stars like Antares in the Scorpius constellation also exhibit changing brightness. Antares is a red supergiant about 12 times the Sun's mass and 700 times its diameter. Another notable star is Mu Cephei, also known as the Garnet Star, located in the Cepheus constellation. With a diameter approximately 1,500 times that of the Sun, it's one of the largest stars known. While these red supergiants share similarities, each has unique characteristics. For example, Betelgeuse's pulsations make it grow brighter and dimmer, while Antares can appear less bright due to gas and dust clouds that obscure its light. Conclusion: studying stars like Betelgeuse, Antares, and Mu Cephei reveals crucial insights about the universe. Each star's unique features help astronomers understand how massive stars evolve and how they eventually die. Betelgeuse remains one of the most brilliant stars visible to the naked eye, constantly reminding us of the ever-changing nature of the cosmos. By observing these stellar giants, we gain a deeper appreciation for the extraordinary forces shaping our universe. Mu Cephei is quite possibly one of the most brilliant stars that should be visible to the naked eye. It is renowned for its brightness, which depends on its throbs, color changes, and general attributes. These stars are nearing the end of their lives with a supernova, a massive explosion indicating the death of a star, possibly happening soon for these supergiants. At first, the thought of such an explosion might seem astonishing, but when you understand what it really is, you uncover a more frightening truth. Supernovae are among the most powerful events known to man, and for a brief time, they can shine brighter than entire galaxies. For example, Antares and Mu Cephei are red supergiants, but they differ in fascinating ways that make them intriguing to study. By observing changes in their mass, brightness, and behavior over time, astronomers can learn a great deal about how massive stars live and die. Astronomers are still monitoring these stars for signs of their eventual demise, making their study both fascinating and significant, especially since it's possible they will end their lives in spectacular supernovae. Supernovae are some of the most powerful and destructive events in the universe, as they release immense amounts of energy. There are two main types of supernovae, Type 1 and Type 2. Type 1 supernovae occur when a white dwarf, the dense remnant of a low-mass star, accumulates matter from a companion star until it reaches critical mass. This causes nuclear fusion to spiral out of control, leading to an explosion. While this event is devastating, it is not as powerful as a Type 2 supernova. When a massive star runs out of nuclear fuel, it collapses in on itself and explodes because it no longer has the energy to counteract gravity. A tremendous amount of energy is released as heat, radiation, and light. These explosions can be so bright that, for a short time, they outshine their entire galaxy. However, the brightness only lasts for weeks or months. During the explosion, everything in the vicinity is obliterated. The eruption of a supernova initiates a process called nucleosynthesis, which creates heavy elements like iron, nickel, and gold. The extreme heat and pressure of the explosion forge these elements, which are then scattered into space, contributing to the formation of new planets and stars. Supernovae play a crucial role in the cosmic cycle of birth and death, as the death of one star makes way for the formation of other celestial bodies. Both types of supernovae are incredibly powerful, though Type 2 supernovae are larger and have greater impacts. These cosmic events are vital for assembling elements and building new solar systems. Supernovae are an essential part of the universe's constant cycle of change. A supernova is a complex and dramatic way for a star to die, but it also paves the way for new stars to form. When a supernova occurs, it sends shock waves through space, compressing nearby clouds of gas and dust, which can lead to the formation of new planets and stars. The death of one star giving rise to others illustrates the universe's ever-changing nature. Not only do supernovae help create stars, but they also provide valuable insights into the universe. Astronomers use supernovae as standard candles to determine the distance to faraway objects in the universe. By measuring the brightness of Type Ia supernovae at their peak, researchers can calculate their distance from their host galaxies. This method has been instrumental in measuring the expansion of the universe and discovering dark energy. A supernova is also a breathtaking sight, as it releases massive amounts of gas and dust into space, forming clouds with vibrant colors and intricate patterns. These nebulae vary in appearance depending on the type of supernova and the surrounding material. The Crab Nebula, the remnants of a supernova first observed in 1054 AD, is one of the most studied objects in the sky. Although they are beautiful, supernovae are extremely dangerous. They release radiation, particularly gamma rays, with immense energy. This radiation can damage DNA and other critical biological molecules, the building blocks of life. Additionally, the shock waves from a supernova can destroy everything in their path, while also compressing clouds of gas and dust to create new stars and planets. These powerful forces highlight the dual nature of the universe, both creative and destructive. A star like Betelgeuse or Antares could one day explode in a massive supernova. A nearby supernova, especially from a star like Betelgeuse, has raised concerns about potential impacts on Earth. While it is unlikely that a Betelgeuse supernova would directly affect Earth, the potential consequences could be significant. A supernova could send shockwaves that alter Earth's atmosphere, climate patterns, and even life itself. The explosion could also disrupt Earth's magnetic field and destabilize the ozone layer. These effects could have long-lasting impacts on ecosystems, land life, and the environment as a whole. While Earth seems safe from Betelgeuse for now, the unpredictable nature of cosmic events reminds us of the importance of understanding how stars behave. Advancements in telescopes and observational techniques allow scientists to study these stellar phenomena with remarkable accuracy. This knowledge helps us better prepare for the potential dangers posed by these cosmic events. The possibility of a Betelgeuse supernova serves as a reminder of the dynamic and ever-changing nature of the universe. The potential death of a star like Betelgeuse offers a fascinating perspective on the life cycle of massive stars. As it nears the end of its life, Betelgeuse will likely undergo dramatic changes, culminating in a supernova. This explosive event is not only a magnificent cosmic display but also a crucial process for the creation of heavier elements essential for life as we know it. One of the most captivating aspects of a star's final stages is how the surrounding space is affected by the massive explosion. As a star runs out of nuclear fuel, its core contracts, causing its outer layers to expand dramatically. In the case of Betelgeuse, this process could result in a massive shockwave traveling through space, carrying immense energy, gas, and dust. The materials ejected during the supernova will enrich the interstellar medium, providing the building blocks for new stars, planets, and even life in distant regions of the universe. The remnants of supernovae, such as nebulae, are often regarded as some of the most visually stunning objects in the universe. The Crab Nebula, the result of a supernova observed in 1054 AD, has been studied for centuries, revealing fascinating insights into the aftermath of such explosive events. The gas and dust expelled from the supernova create intricate, colorful structures that evolve over time as they interact with other elements in space. These celestial events raise questions about the role of these cosmic forces in shaping the evolution of the universe. They challenge our understanding of time, space, and the fundamental forces of nature. Although the chances of a Betelgeuse supernova directly impacting Earth are minimal, studying these cosmic phenomena provides critical information about the workings of the universe on a grand scale. Understanding the behavior of red supergiants like Betelgeuse helps astronomers predict the fate of similar stars and even assess the potential for life in other solar systems.